Examples 5 and 6. We're asked to expand the quantity of x plus 1 to the third power in example 5. Now this one looks a little different than the ones we've been doing because we've had a's and b's in them, but the strategy that I would propose to you here is let's just take this and treat this as a plus b to the third as we start. Now we can use Pascal's triangle to do the expansion if you would like to do that there, right? We'd say here, all right, we're talking about the exponent is 3, which means we're going to have 4 terms, and they're going to have those coefficients 1, 3, 3, and 1. So we're going to say 1 times something plus 3 times something plus 3 times something plus 1 times something. And then hopefully we're getting the part with the exponents down with our variables, right? Remember, we're going to start with a to the third. This would be a squared, a to the first, and then we have no a in the last one. And then we'd have no b in the first one. We'd have b to the first here. Remember, they will add to 3 in your exponents. So then we have an a to the first, we have to have a b to the second, and then the last one, since we have no exponents in there, we'd have to have the b to the third. Now, what are we going to do with this now that we have this? Well, we're going to treat our x value as a and our 1 as b. So wherever we have that a, we're going to substitute in our x. So actually, let me do this. Let me change the color here. So for all of my a's, where I have an a, I'm going to substitute in an x value. And where I have a b, I'm going to substitute in a 1. So it'll look like this. So I still have my coefficient of 1. Now it's really important that you're putting parentheses around different parts here, especially when there's numbers that are going to be put in. But we have 1 times x to the third plus 3 times x to the second times b, which is going to be 1 to the first plus 3 times just an x times a 1 squared plus a 1 times our b is 1 to the third. You can just see here, right, everywhere where I had the b, I now have a 1 in its place, and everywhere where I had the a, I now have the x in its place. And now all we're going to do is just simplify it down. 1 times x to the third is just going to be x to the third power. Here we've got 3, and then we've got 1 to the first. Well, 1 to the first is just 1, so that's really nice on this problem. When you're just adding 1s, it makes it easier. 3 times 1 is 3, and then we have x squared. The next one here, you've got a 3, and you've got a 1 squared, which is just 1 again, so we'll have plus 3x. And then the last one, we have 1 times a 1 to the third, which is just going to be 1, and that gets us our answer, x to the third plus 3x squared plus 3x plus 1. Let's try example 6 here. Now we've got an x minus 2 to the fourth power. So since it's to the fourth power, we're talking about the fourth row here, which means we're going to have 5 terms. We're going to take this here and we're going to set it up as 1, and then we're going to be multiplying that times something plus, we've got 4 times something plus 6 times something plus 4 times something plus 1 times something. And that means here, since we're talking about degree of 4, our a is to the fourth, a to the third, a to the second, a to the first, and then we'll leave out the a to the 0. And our b value here, remember the first one here is like b to the 0, so we don't need it. So then b to the first, 3 plus 1 is 4. B to the second, 2 plus 2 is 4. B to the third, because 3 plus 1 is 4. And then this would have to be a b to the fourth there. And now we're going to take it and just substitute in, right? We've got our a values. We'll be substituting in an x in their places. And then we will be substituting in a negative 2 for the b values. Let's take it here and let's swap them out and see what happens. So we have, 1 times an x to the fourth. I can just go ahead and make it x to the fourth since I know that's what it's going to be. And I have 4 times x to the third times negative 2. Okay, make sure you put that negative inside the parentheses there with the 2. Now we've got plus 6 times an x squared times a negative 2 squared plus 4 times an x times a negative 2 to the third plus 1 times negative 2 to the fourth. Okay, it may seem like it's long here, but it's way shorter than taking it and having to multiply each of the binomials times itself over and over. Now you just need to be careful as we're simplifying. So we already know this is x to the fourth. So here we've got a 4 times a negative 2, which is going to give us a negative 8. And then we have our x to the third. For the next one here, we've got a 6 and we've got a negative 2 squared. Well, 6 times negative 2 squared, that would be 4, so we're going to end up with 24. So we have a positive 24 x to the second power. For the next one here, we've got 4, and then we've got negative 2 to the third. Well, that's like saying 4 times a negative 8. 4 times negative 8 is negative 32. So we're going to have a negative 32 x to the first. And then our last one here, we have 1 times a negative 2 to the fourth. So since it's an even exponent, we know it's going to be positive. So that would be plus 16. And that is our answer.